Welcome to the hands-on tutorial. We'll build a federated learning system using Flower and MNIST dataset. And you'll be provided with code with mainly machine learning standard centralized code for centralized learning, and your task will be to add Flower functionality. I'm Adam Narożniak, and besides working on Flower, I also studied data science. Firstly, I'll just give you a quick intro. I'll show you the notebooks, and I'll let you work on the problem. You can also ask questions as you go, and we'll try to answer all of your questions. And after some time, we'll present the solutions, and we'll be open to questions also at that time. So problem descriptions, we will have notebooks in Colab, which you'll have links to click on, and we prepared two versions, one with TensorFlow and one with PyTorch. Actually, you can pick a framework of your choice that's different than this one's, but we'll have one notebook that is that has some blank spots, blank code that you'll need to fill in. It's commented there, and at the end we'll also have a fully solved notebook. So even if you didn't catch some point or anything like that, you can come back to that part and check it slowly on your own. Yeah, so Flower functionality will need to be added, and most of the machine learning, centralized machine learning is already created for you, as well as the data downloading and very quick exploration of the data. Actually, yeah, here we have two links. I'll try to send them in a second. To the notebook, so you can open them up, and I'll also show them in a second on my screen, so we can just make sure that you know what parts you have to fill in. Yes. So ML models definition, train test function in case of PyTorch, and downloading is done, and data division, Flower client class, Flower strategy, distributed evaluation and centralized evaluation. It's that's the parts that need to be coded, and let me show you how it looks like. Yeah, we have basic exploration of the data, and that's how it looks like when there are parts that you need to code up. So we have the docstrings with the definition of what the function is supposed to do and what it returns. You have an error, and you just remove it, and you write up what you think is should be here. And we have a few functions like that. Sometimes you have some additional stuff to even make it easier. And for example, here, if the code above works well, this function should work, and you should be able to get the results here. Yeah, and here's the machine learning part that we've already provided you with, also the training loop. So this is standard centralized machine learning. Here we're testing if it works in the centralized way, and some helper functions, and we're coming back. Flower client, this is also some part that you'll need to fill in. We will just provide you with initializer, and here are some parts that needs to be done. And if anything is unclear, feel free to ask questions. And at the end, you should see after filling up all the code that needs to be filled, you'll be able to automatically train your model by starting the simulation, flower simulation, and you'll have a history with the metrics with showing how well does it go. And final step, we add centralized evaluation. And the same thing, you'll have the history and you'll see how the model works. So I think is there a question for me? It's quite similar for TensorFlow. I can just quickly show you.
Do you want to also put it in the Q&A part?
Yeah, let me just send you the links right after. Yeah, so it's just justice for TensorFlow. So okay, like especially some differences in model training and yeah. So I'll stop sharing and let you work, and just I see not everyone has laptops here. So if there are anyone in the audience who doesn't have a laptop but wants to still work on the problem, maybe you can join the closest person, or you can try to team up. And yeah, if you feel like it and you will have many questions, we'll try maybe also live coding if there's anything that is troublesome for many of you. And if not, we'll go through the solutions also step by step with explanation in some time. Okay, so in some time meaning about 11:45. Hello, welcome back, and we will go through the solutions now. Of course, if you have any questions, you can feel free to ask them, and let me share the links with you or not. It's solved. Okay, I cannot share them, but let me go. Let's start with TensorFlow, and I'll run it cell by cell. We'll have simple installation. Okay. Will take a second. Okay, and then we can have imports. Just one thing we do is we're forcing to train on the CPU, and in TensorFlow by default you train everything goes to the GPU. So that's just one thing.
Speak a little louder?
Yes, speak a little louder, sure. We define a few constants: seed, number of clients, batch size, validation fraction, and it's for local division of the local data sets, and number of rounds, number of federated learning rounds. And the data, okay. The aim of this section is to create a divided MNIST data set to simulate federated learning environment. Yeah, we provide you with download data function and want you to implement the following: partition data, train, validation, divide, local data sets, you're given function prototypes. Yeah, so the downloading is quite simple. We use TensorFlow's MNIST data, and we just scale them from 1 to 0. And actually this data is returned in certain shape, and we just I think add the channel dimension to the input data because it's a grayscale images. So that's the only reason we need this reshaping. Yeah, and we have for the visualization of a few labels, right? Everything seems to be classified, at least correctly, have a correct label here, and we can see the distribution of the data. It's quite evenly distributed, and we do the first, that was the first part of the assignment, and we partitioned the data. Here we used a NumPy split function, and it's quite simple. Actually, I can show you just one trick, and if you don't know what a function does, and you're in a Jupyter Notebook, you can just type question mark and the name of the function, and you can have this little helper on this side. Or alternatively, you can go help and NumPy split. So if you're not familiar with that function, you can just check it out real quick. So basically, we have the data set divided, and here we split each local data set into train and validation. So as an input, we have this list of and the arrays. And so what we did here, we expect the as input, actually these two things, and validation fraction. We simply create the index that the last index that we'll take for train, and from that index we'll take for validation. And here we are sticking to NumPy arrays. You can also use TensorFlow datasets, but it's more complicated for such small data. We're completely fine using NumPy arrays. And so we have this function, and now this function just does all the steps that we implemented the functions for. And here we go. We just got the X trains and Y trains and so on. So it's a list, right? And we have it here, the first client. You can check it out, and we have the shape, right? And the number of the different clients is 10, and that's also the length of the this list. We can just kind of do these simple checks. And here we have the model definition. That's the thing that we already had. And here the training centralized so far to check if it works. If it works, we'll let it run for 5 epochs and come back. And while using TensorFlow, everything is a little bit simpler than not everything, but regarding weights setting and getting is simpler, and we have the default functionality already implemented out of the, we can just use this set weights, get weights methods of the model. Oh, that's what we do here. This function, get parameters, was required to implement, and we just add this thing using TensorFlow methods, and we have fit, we compile, we set weights, and we fit it. we return model weights, length of the training, and the metrics. Actually, in that case, it's empty, but it might be the same as here. We could return like accuracy or whatever metrics we prefer, and we evaluate. So we also get parameters and config, and we return the same things as we needed for the fit method. And actually, we set weights because we sample for training, meaning for the fit function, we sample clients, and then the weights get aggregated, and then we sample the next time for the evaluate. Yeah, and that's when we also need to get some weights and set them, because yeah, we were evaluating, we were getting the new aggregated weights. Yeah, and yeah, so that was Flower client, right? It's an abstraction that we need for simulation, actually, for the normal training, like non-simulation too. And what we are using, yes, is now also another requirement of Flower simulation, which is create client function. It just has to return Flower client and takes a single parameter as input. It's client ID, and we instantiate the model here, we create it here, and we use the data that we divided before. We index it here. We just change the string ID, client ID, which is an integer in that case, and we use it. We index the list of all of that, and yeah, we create the Flower client, which is just the thing that we had above. Did I run it? Yeah. Yeah, we use the fact that we use that we are in a Jupyter Notebook, so we have access to these parameters without specifying them as arguments here. If we were not in a Jupyter Notebook, in that case, you can create a function that returns a function, or you can use function tools, partial function from Python, and it does basically the same. So you have a function that takes all X trains and then returns a smaller that just has this client ID. And yeah, we want to aggregate the metrics that we calculate. We just use accuracy, so that's what we're going to do. We need that utility function for just that. And here's strategy. So we're going for federated averaging, and we just specify the number of clients, and the thing that we can put some attention into is the evaluate metrics aggregation function, which is the weighted average that we had here. If we had some metrics also for the fit, which we don't, it's empty in the client, we could also specify fit metrics aggregation function, I believe. Let me just check. It's yeah, we have fit metrics aggregation function. If we return just if we had accuracy, we could just give it the same weighted average, but we return it empty, so we are leaving this edit as it is. We could also at this stage create a custom strategy. And we're coming to the very end, which is simulation, starting the simulation. And we use the building blocks that we created before. So client function, number of clients, config, actually, yeah. So we just specify Flower server config and to give the number of rounds. We could have left it empty, but I guess it'll have some defaults with smaller number of rounds, strategy, and client resources. In our case, it will be 2 CPUs, and we'll have it training. Okay, we'll come back to the results, but we can just have a look at the last thing, which is adding centralized evaluation. And in order to accomplish that, we'll create a evaluate function and take server rank parameters config. Right, we do pretty much what we did before. We pretty much, it's very similar to what we did before in the evaluate function, which is we create a model. Yeah, we compile it, which is a TensorFlow thing, and we build it. Actually, yeah, let me give just a word about building. In the model that we had, I didn't specify the input shape. And I think that that's the main reason that we do the building for, because it'll just initialize the weights without having an input layer or specifying input shape. We need to do it that way, but you could also just specify it in the model. So yeah, we build it, we set weights, which will get the aggregated centralized weights. And we use also TensorFlow utility function evaluate. We use X-test, Y-test, which is just the part of the MNIST data set that was tested. We divided the train into all this partition, and we left this empty, so the data set that we use here does not overlap. And this is an optional part of federated learning because this data in real life would have to be on the server. So not every time we have the opportunity to have some part of the data on the server. And yeah, in that case, let's say we have, and we are able to get something that is reliable and quite yeah, steady. And what we do here is we have this function evaluate, which is for centralized evaluation, and we have to specify it in a strategy, which we have evaluate function, which is let me find it. Yes, evaluate function. Right. So we have it. And at the end of each round, we'll have this centralized evaluation. Before running this cell, we can come back and no, it's still running. Actually, there was like some TensorFlow warnings which cannot be suppressed easily, but it's just because that we're using Jupyter Notebook, and it's related to the fact that we don't have the TensorFlow cannot access the code of the model, and it's this error is not. It doesn't appear in case of the standard Python file. Here, maybe if we squeezed everything to a single cell, we could have avoided it also, but it would make everything not readable. So we're gonna deal with this. Yeah, we'll let it run for a second, and also we can queue in the remaining cells, which is this evaluate cell with centralized metrics and history. Yeah, so this step is the same as above, with the small addition of evaluate, but we're starting simulation the same way. Yeah, we can let it run and see the results. And in the meantime, if you have any questions, feel free to ask them, or I can go back to some parts of the code that maybe were not clear, or that you struggled with while implementing it yourself. I think we have a question.
Yeah, somebody's asking if you can post a link to the solved code.
Oh yeah, I don't know if why I cannot, because my Zoom is as.
Oh,
can I send it? I can send it to you. Can you post it? Yeah, sure. So let me go. It's TensorFlow, and yeah, okay. Yeah, there will be online in a second. So this is TensorFlow. This is PyTorch. We're going to go through the PyTorch in a second. Yeah, still running. So how about, oh, there is a new question. Oh, no, that's you.
Yeah.
Okay. So we can go to the PyTorch and we'll come back and check the results in a second. We'll let it run, unless there are any questions regarding TensorFlow. No, I don't think so. Okay. PyTorch also, let me skip the part that is exactly the same or pretty much the same. Yeah, in PyTorch, in order to decide on the CPU, GPU, you do it that way, quite different than in TensorFlow. We're going for CPU the same way as we did before. And yeah, the download is similar. We're just using PyTorch NIST also downloader instead of TensorFlows. Okay, and we have the data. Yeah, works as before. And we have partitioning. So that was the first part that we ask you to do. And what we do is we decide on a partition size based on the length of the data set, and we divide it by the partition number of partitions, and we just take an integer from that length. So the random split, which is PyTorch's function, takes the data set and a list of the lengths that each partition has. So this syntax means that the partition size is just repeated n number of partitions times. So it's like, for example, if it was the size 10 and we had 3 partitions, it would be listed as such. Yeah, just to make it clear. Okay. So we do it and we set the seed. Okay. And now the train validation division of local data sets. So also one difference here, this versus TensorFlows is that we use a single object. In TensorFlow we kept X and Y's, and here we have everything put together into a single object. We could have achieved the same in TensorFlow using TensorFlow datasets, but yeah, NumPy is way easier, especially for such small datasets. And so what we do here is quite similar. We use the random splits, and we still have the lengths, which is in that case train length and validation length. So yeah, validation length is just computed easily, length of the data set multiplied by this float, let's say 0.2 in our case, and simple subtraction here. Yeah, we're shuffling train loaders and leaving as it is validation loaders. Yeah, so that's typical. And here, if everything that we implemented works well, should, yeah, be here. Okay, here we have some assert that the number is correct. So yeah, we have this 3 different lists of objects, 2 lists and 1 data loader. That's the part that we provided, the definition of the model, which is a simple convolutional neural network. Okay, and brain test utility functions. I'll also skip it because it's centralized learning related. Yes, and we can, of course, test the functionality using centralized learning, which we just use the first train loader, validation loader, as in TensorFlow. And here comes the difference. In PyTorch, we create these utility functions for getting and setting parameters of the model. Yeah, we define it as follows. But it serves the same purpose. In federated learning, we just do a lot of weights manipulation between models. So yeah, I can just mention that order dictionary is to meet type hints of PyTorch, and dictionary skip order, I guess from Python 3.6 as it is. So the order is still kept. We just need it for hint typing. Not a big deal. And Flower client, so we have slightly different initializer with the single train loaders, not XYs as in TensorFlow, and we use the utility function. So this is simple. This was the first one to implement, and here also we use set parameters and train function that was already provided, and we return weights, the length of the data set, and metrics empty for fit in that case, and quite the similar. Besides, we add the metrics here for evaluate. So quite straightforward. We just changed some of the functions if you compared to the TensorFlow version. Create client function, also logic the same. We have the net convolutional neural network. We create it here, and we access it the same way as in TensorFlow. So we just index from the list that we that we had. Right, and we return the Flower clients with the things that we just got for this specific client. And by the way, nothing stops us from like using some more fancy division and maybe names and so on in more complicated scenarios. So CID is not an integer, and we create some maps and so on with custom strings. Weighted average, our utility function, and federated average. Here, it's completely the same as before. And we are starting the simulation. And the simulation, I think this is completely the same as before. So yeah, the results yet might be slightly different because of the seed and weights initialization, yet like the same. They should be really similar. So when we are waiting for these results, we can come back and check the results from the TensorFlow. Was it the first one? Yeah, that's the first one. Yes, let's say the history. And history is a Flower object. It has a Flower custom object that has loss distributed each round. We see loss is well decreasing, so seems okay. And metrics, which is accuracy, and we went pretty high and started even high. And we can have centralized evaluation. Also, we can check on that. Didn't I print the history? Okay, so let's have a history. And we should see it code history. Let's see it, yes. So we see this additional centralized history. And also, as expected, the loss goes down. If we let it train for more runs, we can also see it increasing. But yeah, we run it for just quite a few rounds, and the same goes for the. We have additionally this history centralized, and we see accuracy increasing. And we should see the similar results here, but still in progress. Yeah, actually, we can let it run, and maybe you have any questions. I can just mention that, yeah, if we sample all the clients, so fraction fit, as we specify, if it's 100%, so we use all the clients that we have in our federated learning system, it should be stable. Also this metric, but if we don't, which is often the case, we can see some fluctuation because of the various data sets. And yes, if we want something that is, let's say, more reliable or easily comparable, because we can see that direct comparison between two rounds, the centralized evaluation comes handy. No, it's actually it's still running. Yeah, still running. We'll let it run, and we can have questions. Yeah. Okay, I think in that case, I'll mute myself. Of course, I'll stay here for a few more minutes. We can also see the results. No, okay. We can see the results, and feel free to ask me any question.